Okay, section 3.5, it says proving lines parallel. So we're going back a little bit. We're going back to around like section 3.2. If you remember, section 3.2 dealt with parallel lines, transversals, and all that kind of stuff. So let's do this. Let's do a quick little review of what we did before, because today's lesson is going to be really, really close to what we did in section 3.2, if you remember back that far. All right, here's our situation. We have two lines, not just any two lines though. In section 3.2, we said that those two lines are parallel to each other. So the way we show that they were parallel was put these little arrows right here. So I've got two parallel lines cut by a transversal. And I knew a lot of things. And we'll just number these just kind of normal, like I did before. I'm not going to write all this stuff down. You can go back and review 3.2 if you need to. But we learn a lot of names for some of these angles, like angle 1. What's the relationship with some of these angles? Like angle 1 equals angle 4 because they're vertical angles. All right, what are some other relationships between angle 1? Well, angle 1 equals angle 5, or angle 1 and angle 5, they're equal to each other as well. They're equal to each other because they are corresponding angles. Angles 4 and 5, they're equal to each other. They both have one arc on both of them. These are alternate interior angles. Let's see, what else we got? Well, 5 and 8 would be equal as well, wouldn't they? So 5 and 8 are equal because of vertical angles. 4 and 8 are equal because corresponding angles. Look at 1 and 8. 1 and 8 are equal because they are alternate exterior angles. Go back and review those. I know that I went through that pretty quick. This is just a very, very brief review on this stuff. Let's take a look at some other angles. What about angle 2? I'll just do this in a different color. I won't have to put two arcs there. So I got the red arcs and the green arcs. Same exact thing. 2 and 3 are equal because they're vertical angles. What else? 3 and 6 are equal because they're alternate interior. 6 and 7 are equal because they're vertical. You could also look at 3 and 7 are corresponding. 4 and 8 are corresponding. 2 and 6, 1 and 5, all this stuff. And we also have this, that 3 and 5, now these, you'd think that everything was equal here, wouldn't you? But 3 and 5 are not equal to each other. They are supplementary. And they're supplementary because the relationship between these angles is that they're consecutive interior angles. This is obtuse, this is acute, and obtuse and an acute would be supplementary in this situation. Notice, all the red arcs are all acute angles and they're all equal to each other. All the green arcs are equal to each other and they're obtuse angles. So when you have two parallel lines cut by a transversal, all the obtuse angles will equal each other and all the acute angles will equal each other. The obtuse and the acute, same thing right here and here, would be supplementary because they're consecutive interior angles. All right, took 3 minutes to go over all that, but I think that's important because what we're going to do here in a second. Here's one more thing about this thing. What did I start off saying? I said if you have two parallel lines. So I was given that you have two parallel lines. Let's write that down. So if you have two lines parallel, let's say it like that. If two lines are parallel, that's the symbol for parallel, then I'll just put a dot, 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 because we pretty much said all that stuff. If the two lines are parallel, then all these things are true. I took 3 minutes to talk about. Then all the corresponding angles are equal. The alternate interior angles are equal. The alternate exterior angles are equal. The consecutive interior angles are supplementary. All that stuff is true if what? If the two lines are parallel to begin with. Right? To begin with, if they're parallel, then all that stuff is true. Well, this lesson is the converse of this theorem. What does that mean? Well, remember we skipped chapter 2? In chapter 2, they talk about converse and stuff. And the only reason I skipped chapter 2 is because we have some other things that I think are a little bit more important at the end, and we just can't cover everything in the book in 1 year. So I decided to skip that. But what a converse is that it's just taking the if and the then and switching them around. So what would this say? So here's all the then stuff. All right, there are special words for this, but I'll just make it easy for you. This says if two lines are parallel, then let's throw one in there. Let's say the corresponding. We'll do the postulate. Then the corresponding angles are equal. We'll say that. So that was our first postulate that we learned. And then there was a list of several more after this. If I wanted to do the converse of this, the converse means we switch the if and the then. Now, when you take a logic class, they would they use different letters to represent that. The if part, right? If all this stuff, they use the letter P to represent the if part. And then the then stuff, this stuff right here, they use a Q to represent the then stuff. All right? Some geometry teachers would be cringing if they heard me say this. But this is how you write it. This is P, this is Q, if then, or if P, then Q. It means if something is true, that the P represents some kind of a phrase. In this particular case, its two lines are parallel. That's the P. The Q represents another phrase, and that would represent the corresponding angles are equal. So our phrase would be, if P, then Q. That would be just the normal statement. I'll show you what I'm getting to here in a sec. I'm just trying to cram a little bit of chapter 2 into this. So if P, then Q is your normal statement. The converse of the statement is this. Let's do that in a different color. If Q, then P. All right, so this time I'm going to say if this stuff is true, then this stuff right here is going to be true. So the converse of this statement would be this. If, there's a little bit more to this, but let me just say it like this for right now. If the corresponding angles are equal, then, see what I just did? I did the if. If the corresponding angles are equal, then what? Then this thing right here. See, that's the P, that's the Q. I started off, I switched them around. Switched the P and Q around. So if the corresponding angles are equal, then what? Then the two lines are parallel. This actually has a little bit more in front of it. It says if two lines are cut by a transversal. Notice it didn't say if two parallel lines. I'll just put a little thing up here. If two lines, if I could spell, if two lines are cut by a transversal, I just say cut by a transversal just to save some writing. If two lines are cut by a transversal and the corresponding angles are equal, so basically it's saying, okay, if I have two lines, let's do this, scooch this a little bit, all right? So it's saying if I have two lines, now I don't know they're parallel to each other. I don't know that. They look like they are, but that doesn't mean they are just because they look like it. There's my two lines, and here's a transversal right here. So if I have two lines that are cut by a transversal, and I don't know they're parallel, notice I didn't put a little arrow thing here. If two lines are cut by a transversal, and if the corresponding angles are equal, that's what I want you to get right there. If the corresponding angles are equal to each other. So let's put some numbers in here. Let's put a 1 here and a 2 right there. So if I was able to tell you that angle 1 is equal to angle 2, they're corresponding angles, right? It says if the corresponding angles are equal, and they are because I put arcs on them both, right? So it means angle 1 is equal to angle 2. If that's true, then what can I say about these two blue lines right here? I haven't said it yet because I didn't know it yet. But now I can say that those two lines are going to be parallel to each other. Do you see the difference? It's a subtle difference. It's a slight difference, but it's the converse. That's what we're doing right here. So instead of saying if the two parallel or if the lines are parallel, then the corresponding angles are equal, we say this. If the corresponding angles are equal, what can I say then about these two lines? They would have to be parallel. So if I measured this angle and this angle, and if they were exactly equal to each other, then I could say these are parallel. Let's do this. I'm not going to bring a protractor out. I thought about doing that, but you could probably try that on your own. Watch, let's take this and we'll rotate it about there like this. What if we did this? Now, those are obviously, they look obviously not parallel to each other, don't they? Because yeah, it looks like they would eventually hit. So watch this. It says if the corresponding angles are equal to each other. Does it look like that angle right there and that angle right there would be equal to each other? And you're looking at it and you're saying, I don't know, maybe they are, maybe they're not. Let's make it even a little bit more drastic. Let's do this. Let's click there, and then there we go. Let's make it even a little bit more drastic, like this. That looks a little bit better. Right? I've got two lines that obviously do not look parallel to each other. So this says if the corresponding angles are equal. What if they're not equal? What if this and this angle, what if these corresponding angles were not equal to each other? And they're obviously not. That looks way bigger than that angle right there. This looks close to 90. It's getting closer and closer to 90. It's probably in the 80s. This is probably maybe in the 30s. So this is way bigger than this. If the and they're still corresponding angles. If the corresponding angles are not equal to each other, guess what's true about the two lines? They are definitely not parallel to each other. So you can kind of look at it that way as well. So let's do a couple more of these. And from here on out, it's going to look very, very familiar. Except they're telling you which angles are equal to each other, and you have to decide if the lines are parallel or not. That's the big difference. Let's make this slant a little bit different, like that. All right. So we already talked about the corresponding angles. What are some other ones? Well, I'm gonna skip a little bit of this. Again, it says if two lines are cut by transversal. Do I have that situation here? Absolutely. Okay. So I'll leave that out, but you can kind of fill in the blank if you wanted to. If two lines, not parallel, just if any two lines are cut by a transversal, and if the alternate interior angles are equal, then what do you think might be true? Let's put some alternate interior angles in here. Let's say that's 3 and that's 4. What if I was able to tell you that angle 3 absolutely equals angle 4? All right, so if I said that angle 3 equals angle 4, what could you say about these two lines? So it says if the alternate interior angles are equal, this theorem says, then those two lines are going to be parallel. We'll call it L and M, the two lines. So if the alternate interior angles are equal, then the lines are parallel. I'll just do it like that. So if you wanted to put those numbers in, we could say this. If angle 3 equals angle 4, it's supposed to be equals, then what must be true? Line L must be parallel to line M. So if I know that those two are equal to each other, I can say right off the bat that, okay, if the alternate interior angles are equal, that must mean that the lines are now parallel. Hopefully you're seeing the difference between what we did in 3.2 and what we're doing now. In 3.2, they started off telling you that the lines are parallel. In this one, they don't. They start off telling you that the alternate interior angles are equal. If that's true, these two lines must be parallel. I think you see the difference now, don't you? And then you can kind of do the same thing. Well, let's just do some more. What if the alternate exterior angles were equal to each other? All right, so let's put those numbers in here. Let's put some numbers in. Let's change colors. What if I said 5 and 6? What if I told you that angle 5 equals angle 6? They're alternate exterior angles, right? So if angle 5 equals angle 6, then what must be true about these two lines? Then the lines are parallel. So look, it ends up the same. Oops, I can't spell again. Then the lines are parallel. So if the alternate exterior angles are equal, then these two lines, L and M, must be parallel to each other. Let's see. So we had corresponding, we had alternate interior, alternate exterior. Was there another one? Let me look at my book. I don't think that was, I think that's all of those type. What about this though? Let's do another picture here. Let's do two lines cut by transversal. Again, I said two lines. I didn't say that they were, oops. I didn't say that they were necessarily parallel to each other, okay? So just if any two lines, now I drew them parallel because I'm going to make this work. But if I have two lines cut by a transversal, and the next thing says, if the consecutive interior angles are equal, so let's write that. If the consecutive, C-O-N-S stands for consecutive, interior angles are equal to each other, then, guess what? Just like before, then the lines are parallel. Okay, these two lines right here, these two green ones. So if the consecutive, oh, you know what? I messed up. Ooh, almost missed that. Not equal. My goodness. That would have been a huge mistake. And let's scooch this over. Okay. Let's try that again. If the consecutive interior angles right here, let's call this, I don't know, 7 and 8, not equal to each other, because look, that's obtuse, that's acute, not equal to each other, but what? If the consecutive interior angles are supplementary, I'll just write that in there, I'll just shorthand it, supplementary, then the lines are parallel. Remember, the consecutive interior angles have to be supplementary, which means they have to add up to 180. So if this angle plus this angle equals 180, then these two lines must be parallel to each other. So if I did this, watch, if I said this was 130 and I said that was 50, if I said that's 130 degrees and this is 50 degrees, what could you say about these two lines? Well, they're supplementary, aren't they? If the consecutive interior angles are supplementary, then these two lines have got to be parallel to each other. All right, so I just proved it. If this and this are supplementary, if the consecutive interior angles are supplementary, then that must mean that these two lines have to be parallel to each other. All right, hope that makes a little bit of sense to you. Let's do another one. Okay, this is another one. It's a little bit different than the alternate interior and all that kind of stuff, but it's not, okay? Because I've got perpendicular right here, okay? And we did one in lesson 3.2 that talked about perpendicular. It said if you have two parallel lines and one line is perpendicular to one of the parallel lines, it's got to be perpendicular to the other parallel line. Well, this starts off saying if two lines are perpendicular to the same line. So here's the if part. So if a line R, is perpendicular to line P, we'll say it like that. I guess I should put the word line in front of it. Sorry about that. Let's start that over. It's a mess. Let's try it again. So if line R is perpendicular to line P, this is what this theorem says. It says, let's see, if two lines are perpendicular to the same line, right? No, that's not how I want to say it. Let's try this again. Sorry, my bad. Let's try it like this. I wasn't doing the converse. This is the converse. If lines P and Q, let's say that. If lines P and Q are perpendicular to the same line, all right? So let's see, perpendicular to the same line. Yep. If lines P and Q are perpendicular to line R, right? We got two different lines perpendicular to the same line. So if P is perpendicular to R and if Q is also perpendicular to R, what must be true, do you think, about P and R? See, they're both perpendicular, and that means, look at this. This angle would be a right angle. This would be a right angle. And so these would be equal to each other, corresponding angles. So what must be true if the corresponding angles are equal? That must mean that the two lines have to be parallel. So if all that stuff's true, if these two lines right here are perpendicular to R, which it says, then what must be true about P and Q? Then P must be parallel to Q. All right? Sorry about the mix-up at the beginning of it, but I think we got it straight. If two lines are perpendicular to the same line, then those two lines, okay, the two that were perpendicular to this, have got to be parallel to each other, which means they'll never touch each other. Let's do an example, and we will be finished. Okay, here's what the example is asking you to do. You've got two lines here, two white lines, L and M. You got two red lines, A and B, and you know they're transversals. You don't know that they're parallel, right? There's no arrows on here, so you don't know anything about being parallel, but they're going to tell you some things about some of these angles, tell you some relationships between the angles. And so they tell you that, the first one, they say that angle, let's do this in blue, let's say angle 2 equals angle 8. So let's mark it, angle 2, and let's say it equals angle 8. The question is, here's the question, which two lines, or are any lines parallel to each other because 2 and 8 are equal? All right, so what we want to do is we want to find the two lines in the transversal first. So let's take a look. Angle 2 hits this white line L and this red line A. 8 hits the white line L and the red line B. So if you look at it, the white line is the one that hits both of those angles. So that's your transversal. These would be your two parallel, or not, skipped ahead. These would be your two lines. So here's your two lines, here's your transversal. Look at 2 and 8. Is there a relationship that we've talked about between 2 and 8? Absolutely. They are alternate interior angles. And what's true? The converse said, if the alternate interior angles are equal, then the two lines are going to be parallel. Or if you want to say the whole thing, if two lines, this one and this one, are cut by a transversal, this one and this one, and the alternate interior angles are equal, then those two lines must be parallel. So if 2 and 8 are equal, that means that A must be parallel to B. All right, let's do that again with some other combination of angles. That wasn't too hard, that one. They get a little bit harder. Angle 3 and 11. Angle 3 equals angle 11. All right, so let's just take a look and mark that. Angle 3 is right here. Angle 11 is right here. And they tell you they're equal to each other, so I'll put an arc on both of them. Now, which one's the transversal this time? Now, if you look at it, 3 connects these two lines, and 11 connects these two lines right here. Hold on, I got a call from my wife. I got to take that. Okay, thanks for waiting. It was a good call. We're going out to dinner as soon as my wife gets home from work. So anyway, let's take a look. 3 and 11. If 3 and 11 are equal to each other, is a relationship. Again, this angle connects A and L. This angle connects A and M. So which one is the transversal? It's the one that's shared by both of them, which is the A. So that's your transversal. The L and the M would be your two lines. Let's take a look. Is there a relationship? Absolutely. 3 and 11 are corresponding angles. If the corresponding angles are equal, then the two lines have got to be parallel. So now I could say that line L is parallel to line M because 3 and 11 are equal to each other. Let's do another. Angle 12 equals angle 14. Let's take a look at those. Let's get rid of these now. All right, let's take a look at 12 and 14. Well, let's mark those. There's 12 and there's 14. Let's see, angle 12 is formed by line A and line M, 14 by M and B, so A and B are your two lines. M is your transversal. 12 and 14 are alternate exterior angles. And we do have a theorem that says if the alternate exterior angles are equal, then the two lines are parallel. So yes, A and B must be parallel to each other. All right, let's do this one. This will be the last one. Angle 1 equals angle 15. Let's see if there's any relationship between them. Let's get rid of these little archy things here. 1 and 15. So here's 1 and here's 15 way down here. Again, let's see if there's a relationship between them. Now let's see what lines are forming this angle right here. So angle 1 is formed by line L and A. 15 is formed by B and M. Do they have anything in common? Do they even have a transversal? No, they don't. They don't have anything in common, all right? So you do not have the situation where you have two lines that are cut by one transversal. These are two completely different lines than these lines up here. There's no transversal. There's no common line. So you can't say anything. Just because 1 and 15 are equal to each other, you cannot say anything about any of these lines being parallel. So you would just say it's not possible to tell. So I'll just put not possible. And there you go. Let's do one more example. We got a couple minutes, and I think this would be helpful to you. Okay, here's the last one we're going to do. I promise this will be the last one. It says find angle MRQ. Let's find that. MRQ. That's this one right here. It's that angle right there. That's what we want to find so that A is parallel to B. This is line A. See the little A right there? That's line A. This is line B. We want to find what this should equal in order to make this line parallel. Well, it's that whole converse thing. Remember, if certain things are true, in this case, look at this angle here and this angle here that they give us. What's the relationship between them? They're alternate interior angles. If the alternate interior angles are equal to each other, if I marked this equal to this, if they're equal to each other, then this line A is going to be parallel to this line B. So how can I get them equal to each other? Well, let's set them equal to each other. Let's solve for x, plug it back in, and then you can figure out what MRQ is equal to. The math is exactly the same as if I would have started off saying, these two lines are parallel, find this angle. Then what would you do? You'd set them equal, solve for x, plug it back in. It's basically the same thing, basically, all right? With a little bit of a twist. It's saying find what these angles should be in order to make these two lines parallel. Well, we still have to set them equal to each other. So I'm going to go 7x minus 21 equals 5x plus 7. Then you do the math. Subtract a 5x is 2x. Add a 21, which will give you a 28. Divide by 2, and that gives you a 14. You're not done because it says find what? Angle MRQ, which is this angle right there. So we just take this and we plug it in. So it's 5 times 14 plus 7. Let's see, 5 times 6, 12 is 60, that's 70, 77. All right, so that angle would be 77 degrees right there. So angle MRQ would be 77. Guess what this would be? Without even plugging the numbers in, guess what it would be? Sure, it'd be 77 because they're alternate interior angles. And if they're equal to each other, remember, big if they're equal to each other, then these two lines have got to be parallel. So if this was 77 and this was 77, that would make both of these lines parallel to each other. All right, I hope that helps. Good luck on your homework on this.